Okay, guys, I'm back. Video number 2, how to create your own original calorimetry problem. You know, that's what I signed for you to do this next 2 weeks. I figure you really should try to dive in and get it done this week, not put it off, because it will help you as you prepare for the lab next week. And that way you won't have so much work to do that next week when you're preparing a lab report, a module test, and then an original calorimetry problem. If you go to the files and links in the Jupyter Ed, you will find a file called How to Invent an Original Calorimetry Problem. You can print that off and use the worksheet that's there to help you create this. And I think I also sent an email and it was attached to that. So let's just walk through it. My last video took 30 minutes, but we worked 2 problems. So hopefully this one will be shorter. I don't want you to fall asleep. At least you could pause it and then come back to it. But anyways, I'm just going to walk you through what I did to create a calorimetry problem yesterday afternoon as I was thinking about how can I do this to make it easier for the class. Is there something I can do to help you? Give me some feedback. Let me know if it's really did help for me to do an additional lesson that you could watch at another time. So the very first step is to create the chart. You know that's coming, so I went ahead and put it up on the board so we wouldn't waste time drawing it. You're going to put all 3 things across the top, even though you're like, I'm not using the calorimeter, just put it up there for now and just, you know, give it a chance, because you might get working into it and think, oh, well, it might be interesting to throw a calorimeter in there too. So put it up there to begin with. Decide, that's your next step. Decide, am I going to use the calorimeter? Am I going to include it as part of the problem? It really doesn't add that much work to what you're already doing. Just one like additional subtraction, I think. But for my problem, I didn't want to include it. So I'm just going to, I can X it out. Okay? I'm not going to use the calorimeter for my original problem. Step 3 is to decide, what do you want this student, this person out there, whoever's working these calorimetry problems, well, actually ends up being me, what do you want me to calculate for you? And any of these are up for grabs. You just have to pick one of them and circle and say, okay, that's what I want them to calculate. For my problem, I wanted them to tell me the mass of the water, okay, the mass of the liquid. We have liquid up there because the last problem we did had a liquid and not water. I'm changing mine to water. Yeah, my writing is really bad on this board because it rocks back and forth and it makes it hard to keep up with. Okay, I decided that I want the student to figure out what is the mass of the water. Okay, and I try to do some kind of thing like this. You know, something like that that makes that box look different than the others. Because when you start dropping in information that you just have to think up yourself, you might accidentally throw a number in there and then you get to the end and go, wait, what was I trying to figure out? So just to help me keep track of it, I'm very visual. That's why I do this. I darken that, or you could, you know, like shade it in or something like that. So then your chart should kind of look like that. Maybe not with this much at the bottom. Now we have to decide the particulars for our object. What kind of object are you going to work with? What are you going to have? What do you want to happen? Do you want it hot and it's going to cool down? Or you can make it cold and it's going to warm up. Okay, and that's kind of what I actually, to tell you the real truth, I was sitting there at my kitchen counter as I was starting to work on the problem, and I looked over on my on the wall. I have a big shadow box, and there's all kinds of different things in there. And my great big glass marble shooting, you know, one of those big shooter marbles if you're playing, if you ever play marbles, a big white glass marble. I said, oh, that's going to be my object. That's what I want to use. So that's how I decided what I wanted. I just kind of looked around the room and went, oh, okay, I'm going to, that looks good to me. You know, There was a metal one sitting right next to it, but I wanted the glass one. Something about the glass one just kind of jumped out. So my object is going to be glass, okay? And you just have to think of how much am I going to have it weigh. You can have it weigh however much you want. This is imaginary numbers. I took my marble and put it over on my scale, and I found out that it really is 15.7 grams. And because it's glass, I know that its specific heat is 0.8321. No, 8372, sorry. Okay, those are given. I didn't, but whatever you decide that you're going to use, you have to make sure your specific heat matches. I looked up the specific heat with glass. Actually, it was in the textbook, so it was really pretty easy. Don't make it harder for yourself than it has to be. So the next thing we have to deal with is this temperature thing. What do I want to happen in my temperatures? I kind of decided I wanted mine to be a little bit different. So instead of heating up that glass marble, which I think would be a little weird, I'm going to put it in the freezer. I'm going to have it be cold, and it's going to drop into some water, and the water's going to heat up, and my object is going to, my object is going to heat up because it's below 0, and it's going to heat up to 0, and my water is going to be above 0, and it's going to cool down. So it kind of reverses our signs that we did in class, but I don't know, I'm kind of weird that way. So I kind of started to have an idea of what I wanted my temperatures to do. And but that's where I kind of ran into a problem too, because to look at the temperature of my room, it's in Fahrenheit, and to look at the temperature of my freezer, it's in Fahrenheit. And so I either had to just sound weird and say, oh, the room was a nice 25 degrees Celsius, which is like 77. That actually sounds a little bit too hot to me, but that's kind of a given. Normal room temperature is about 25 degrees Celsius. So I either had to sound weird or I had to make the student convert. I didn't want to make the student convert it, so I'm just going to sound weird. Maybe I am kind of weird, but that's okay. No comments. So I decided to put my glass ball in my freezer. My refrigerator and freezer actually do have a thermometer on it, and it told me its temperature, which I had to convert. And I came up with, it's my freezer, my object is going to start out at negative 18.9 degrees Celsius. Okay, negative 18.9. And it's going to warm up to the freezing point of water, because it's going to freeze the water that's in my cup. So it's going to end at 0. That's what I decided. Kind of looks like a happy face or something, which means that this one's going to end at 0 as well, okay? And my water is going to start at room temperature, which is 25. Okay, so now I can calculate what my delta T's are, okay, what my change in temperature is going to be. Watch out for this sign right there, because when you take 0 minus a negative number, you end up with a positive number. And it ends up being 18.9, okay? Which kind of makes sense because it's warming up to freezing point. It's below freezing and it's going to warm up to freezing. Anyways, just humor me. 0 minus 25, and it's going to change by 25. Okay, and I circle these so that as I begin to work the problem, I don't accidentally enter one of those. Okay, you don't want to make that mistake. You want to get these change in temperatures correct. This is super high for most changes in temperature. Usually it's only by like 1 degree or 2 degrees, just so you know. So now my chart kind of looks like this. I already know the specific heat of water is 4.184, so I can enter that. Okay, and now you see that you have everything you need here to calculate your energy, and that's your link across to this energy, because these two are the same, right? Energy cannot be created or destroyed. It has to come from somewhere. So if there's coldness, actually if there's heat coming off of the water, it has to be going somewhere, and it's going there. So these two numbers are the same. The only difference is the sum. So let's calculate the one for the object. I'm going to erase this. Okay, let's just go ahead and fill this in. For the object, Q equals MC delta T. MC delta T. 15.7 times 0.8372. I'm still running off this board. Let's come off one more time. And 18, positive 18.9. Okay, so that should give me a Q. We just have to calculate it. 15.7 times 0.8372 times 18.9 equals 248. Check that. Yep. Okay, so we entered that, and I get 248. I have 3 significant figures here and 3 there, so I can leave it there. 248 joules is my Q for the object. Okay, that becomes my bridge to here. If this is warming up, then this one has to be dropping. 248 joules. And then you can see, I'm going to work it for water. And let's rearrange it. Q equals MC delta T. I want them to calculate the mass. So I need mass by itself. So let's cancel the C's and cancel delta T. So those cancel, right? Leaving me with M equal Q divided by mass, no, Q divided by C delta T. Okay, hope that makes sense. If not, type me a question. Ask me about this in an email, okay? Let me kind of put this more like this. But I just plug in. So I now have, this is water, negative 248 joules divided by 4.184 times negative 25.0. The negative signs are going to cancel each other out. So now I have a positive mass. Can't have a negative mass, right? It's below existence. That doesn't make sense. So mass has to be positive. And we just enter it in to 48 divided by left-hand parentheses 4.184 times 25 right parentheses equals 2.37. Mass equals 2.37 grams. Okay, so that's going to be their answer. 2.37 grams. That's what they're going to find when they get to the end, which, if you measure that out, it's about, you know how when you drink something and there's just like this little half a swallow down in the bottom of your glass, that's about 2.37 grams. It's just not very much. So once you've done this, then you create the story. So then you can read my problem at the bottom of the page. And the only thing I forgot was I was supposed to include how much the marble weighed. And I forgot to give that information. So maybe out at the end, I would say the package that I bought the marble, that the marble came from the store in, said it was 15.7 grams or something kind of like that. So I need to throw that information in. You'll have to read my problem, see if you like it. And I hope this makes sense on how to create your own problem, and kind of how I thought about it as I put it together. Hope it helps.